Thank you. 39 minutes, Miss 5. Hello, so my name is Mathias Bodo, as Jörg said. I'm not going to introduce myself once again. Today in this presentation, I like to share my experience while trying to answer this question. Would I gain in productivity by applying the concepts of framework, reusability, and modularity to user interfaces? We know those concepts for reusable libraries, but what about user interfaces? So the traditional way of developing user interfaces with LabVIEW is by creating a more or less static front panel with controls, indicators, splitters. You take them from the palette or from Quick Drop, and you build your application's user interface this way through one or more VIs. And in this situation, the business logic of your user interface, your front panel, is done directly on the associated block diagram, right? Using the direct relationship that LabVIEW makes between the front panel and the block diagram. You can use subpanels to have something more dynamic, but what I'm showing here represents the essence of a LabVIEW VI. In other words, the business logic of an application is directly coupled with the user interface, making that UI not much reusable across different applications. For example, the way we would implement this application is by having some buttons at the top. They define the menu, acquisition, or configuration. And then you have an horizontal splitter with a subpanel at the bottom where you can dynamically show the acquisition user interface or the configuration user interface. And for example, in the case of the configuration interface, you can also have another splitter, vertical, a list of the configurable elements on the left, and another subpanel on the right where you show the different configuration user interfaces. So the subpanel allows us to dynamically show one or another UI, but each UI, each VI, will most likely have its business logic directly on its block diagram, such as writing to the config file, launching and acquiring some samples, this kind of stuff. Now imagine we are implementing this application in a completely different way, where we could dynamically at runtime instantiate a container. This is a horizontal container, horizontally splitted. And you have two panes on that container, and on pane one, we would dynamically at runtime load our menu buttons UI. And on pane 2, we will dynamically at runtime load another container, this time vertically. And on pane 1, we would dynamically at runtime display a list UI. And on pane 2, we would dynamically at runtime load different configurations UI. They could be specific to a particular instrument or a particular use case, such as logging, permissions, whatever. And the big difference is that now the business logic of the user interface is completely, the business logic of the application is completely decoupled from the user interface. It's running elsewhere. And basically, to do that, you would be able to, you need to tell the UI what to show. It could be the button name, the color, the glyph, the items in the list box. And each UI would be able to report user interactions, to report what happened, so the application's business logic can take decisions. And cherry on the cake, all those things will resize nicely if you resize the window. And to achieve that, we need a UI framework because there is a lot of things going on. What is a UI framework? It is a software API that enables building user interfaces for application. It provides the foundation for creating user interfaces on which every application can be designed, and it comes with rules that you need to follow, benefits that you can take advantage of, and constraints that forces you to follow a certain pattern. And I decided to base our UI framework on another well-known development framework, DQMH. I'm not going to introduce DQMH. Just raise your hand if you're not familiar at all with what DQMH is. Good. So I continue. Our UI framework consists in UI modules, which are actually DQMH modules, a little bit modified. They are clonable, so we can run multiple instances of a UI. And since they are DQMH modules, they come with their API tester, and they implement the traditional QMH design pattern that we are all familiar with. The second UI type are UI containers. They can be defined statically at development time or dynamically at runtime. And when you instantiate a container, you tell it if it's a vertical or horizontal container. And in each pane of the container, there are 2 panes in the container, you can display a UI module or another container. So you can have a nested hierarchy of containers and this way build very complex user interface dynamically. You have UI requests in the framework to tell a UI module what to do, what to show, how to behave, and UI broadcasts so the modules can let the rest of the application know what happened or share some information. And finally, to be able to write code faster and ensure we properly follow the rules and constraints of the framework, we have scripting tools that allow to programmatically generate any of those four elements. Now let's see a demo of how we will create a reusable UI list box based on this framework. So here we are seeing the scripting tool, and we are telling it to generate a UI module called UI list. And this is going to create a new project with a DQMH module, and there is also a class that has been added to it to make it work with the framework. So if we look at the main VI, it looks like a regular DQMH module with a little bit more stuff, again, to make it work with the framework, but you can see your event handling loop and message handling loop. You have the API tester, and you can run instances of your UI, multiple instances. As I said, it's clonable. And here I'm showing the panel of the 3 instances that I've just launched. And I can send requests to one of those instances or all of those instances. So now I'm going to modify the front panel of my module. So I put everything done, and I'm just going to drop a list box. We want to design a reusable list box UI that I would then be able to reuse in any application that needs a list box. So I'm sizing my VI nicely around the list box. I'll configure the list box to scale with the front panel so it resizes nicely. And to be able to manipulate my list box through UI requests and UI broadcasts, I'm going to put a reference of my list box in the DQMH module data cluster. So that comes with DQMH if you're not familiar with. And in the initialize case, I'm passing the reference of my list box or any object that I would like to have on the front panel of this UI module. Now I'm going to create the request I need for that UI to behave. So I go to my scripting tools, and I'm going to create a request called set list items. So I can set the item names of my list box. So the argument of the request is going to be an array of strings of my items, and I don't need any reply for that particular request. So I'm just sticking with the event arguments. And this will script in my DQMH module all the code needed, which is a class that contains the request arguments, and a wrapper VI that I can call from any other UI module or any other part of my application to send that request to a particular UI module instance. It also generates this process UI request VI that is where I implement the business logic of my request. And here I can find my module data cluster, so I can get the reference of my list box and manipulate my list box from there. And in the set list items class data cluster, I'll find my request event arguments. So the list of items that I can populate my list box. The API tester has been scripted too, so I get a button to call this request set list items, so I can then validate it works. And we can see here the wrapper VI that has been generated. I need to modify a little bit the scripting tools because it exposes on the connector pane the class itself, but I believe it should just expose the event arguments, the arguments that are in the class directly if they are less than 3, let's say. So it makes the calling code easier. So that's what I'm doing here. Instead of connecting the class, I'm just connecting the argument. So now I have my wrapper VI that I can use from the tester or anywhere else and send the list items. So let's try this. I'm going to launch the API tester, run a new UI instance, and send a request with letter ABC. And you can see that my UI has been populated. And we start to implement the behavior of this UI, things that are just very generic. So just some tweaking. I like to highlight the entire row, but we could have a request to change this behavior too. We should have probably a request to customize everything. You would pretty much want to expose a lot of VI server properties of that list box through requests to really make a nice reusable list box. Another request, I'm going to set the selected index item. So same stuff, the event argument, it's going to be a numeric, I32, with the index that I want to select. And this time, I'll have also maybe a reply. In the reply, it might be useful to get the previous selected item. So when I call this request, I'm going to reply with the previous index. And again, when I validate the scripting tools, it's going to generate the code in my DQMH module. And I just need then to implement the code in the process UI request. Takes a little while to generate. All right. So this time I'm gonna again retrieve my list box. So set selected item index. I go to the process UI request. I have my module data cluster. I take the list box of my reference. I'm going to read the current value of my list box so I can return it in the reply payload of that request. The reply payload is also a class, and in the members of that class, I'll find all my reply arguments. Here I have just one, the previous index, and that's how I reply. And then we are going to write the new value that I find into my request class arguments. Set that property node to write, and just pass the new index. I could have done that in a single property node, actually. I find it's more readable here. Again, the API tester that comes with DQMH modules has been scripted. I'm going to do the same. Again, I should modify my scripting tool so it's done automatically, but directly expose the index to the connector pane as an input, and the previous index on the connector pane as an output. So the coding code is easier to read, and you don't have to do this code on the coding code. All right, it's done. Now I have my API tester. Let's try this. Creating a control for the new index, an indicator to check the previous index. Instead of having a button to send this request, I'll just connect that request to the index value change. It's just easier. And we can try this. I run my API tester, I launch a new instance, show the UI panel, put some item in the list box, and now as I'm changing the index, you can see that it changes. There is a glitch on the video, but it works as expected, believe me. And it returns the previous index. Screen recording sometimes can be a a little bit fancy. Okay, let's see an example of a UI broadcast, because obviously in my application's business logic, I want to know when the user changed the value of my list box, otherwise there is no point. So that's done with a UI broadcast, something that my module, my UI module will generate to tell the rest of the world, the rest of my applications, another UI module, whatever, that the value of my list box changed, that another item has been selected. And as the event arguments, I return the index, but also the text element corresponding to that index might be useful. It will be useful for sure. So again, the scripting tool will generate the code for that. And now I need to implement this in the main VI of my module. So on the main VI of my module, this VI has been dropped, and that's the VI that will generate the broadcast, the UI broadcast event. Same thing, I need to modify the scripting tools to just connect the event arguments to the connector pane, which are the index that was selected and the text element. Creating a control. I'll connect this to the connector pane as inputs. Another input of the broadcast is the UI name, because you want to let the world know which UI and which particular instance of the UI generated that event. It might be useful for your application business logic. So then I go in the event handling loop, take the list box value change event, and I'm going to enqueue in my DQMH message queue a new message that I'll name probably list box value change. I'll put my list box control into that event so I can find the event directly related to the list box control. And I'm going to duplicate a template frame for the list box value change. And take the property node of my list box with the item names and the value, so I can get directly the text of the element that was selected, index array. And then I use the VI that was generated and just wire my text element and my value and the UI name that I can find at the top, the UI module name. That's it. Now let's see how we would implement receiving that broadcast. And again, the API tester has been scripted for you. And the way it works is that we build an array of all the broadcasts that we care about. So in the API tester of a module, all the broadcasts that this UI module can generate. And then I go iterate one by one. And if I am in the no error case, it means that I was able to correctly typecast the broadcast that came into the one I care about. And I go to the corresponding index. So in this case, index 1 implements the broadcast item selection change, because index 1 is the second element of the array that you can see on the left. So I'm going to put two more specific class to typecast my UI broadcast to the item selected broadcast, UI broadcast, so then I can retrieve the arguments of my broadcast, which are the index and the text, and I'm going to put that in the status log of my API tester so I can validate it works as expected. I run an instance, put some items in the list box, and if I generate a value change event, you can see that we get UI list instance 1 sent UI broadcast item selection change, and you get the index value and the text value, so it works as expected. So now we have a UI list box that I can set the items, I can set the selected index, and I can know when the value changed. So something very generic that now I can plug in any application where I need this UI without having to rewrite all that code. It's a very simple example, but imagine what you could do with something where you spend more time and that you happen to do and redo over applications. I'm going to create quickly 2 configuration UIs just for the sake of this example. So remember, we have acquisition. So I'm going to create a UI config for the acquisition and for the logging. So I use my scripting tools again. It generates a project, independent project. It also generates, I don't show it here in the build specifications, the PPL build specification. So this UI can be built as a PPL, and you can have plugin architecture and really have something really dynamic without even creating static dependencies. So for this UI config acquisition, I'm just going to put number of channels, sample rate, and here you can see I'm resizing the UI to the minimum pane size that I want, and I'm setting in the VI property the minimum pane size because the framework is able to handle that and will make sure that when you load a UI in the main UI that you are showing, that the framework will always respect the minimum size to ensure that you can see all the things that matter on your UI. So another UI, the UI config logger. It's just for the UI. I'm not going to implement anything because we don't have much time. So in this case, it's going to be a file path control that I'll call probably logging folder path or something like that. You can see I'm making it wider, again, to demonstrate how the UI framework will behave when we load this and the initial UI is not large enough. So I'm going to the VI property again and set the minimum pane size, and that's it. Now let's see how the coding code to run this would look like. And since our framework is based on DQMH, it's not surprising to see that the UI framework is also based on DQMH. So the UI framework consists in a DQMH module that is called the UI manager, and the public API of this UI module defines the public API, the software API of my UI framework. So I'm starting the UI manager module, and I pass as an argument an array of search paths, folders where the UI framework is expected to find UIs, whether they are just LabVIEWs or built as PPLs too. When I receive the module ddinit event, I'm going to start to call the start UI and wait function of my UI framework and pass the name of the UI list. So I'm going to start the UI list, call the request setlist items, pass acquisition and logger, and set the selected index to 0. So I will directly select the acquisition element. And I'm defining dynamically a dynamic UI container. The title, it's going to be the main window. So I put a window title, it's vertical, and the pane 1 will show my UI list. And since I selected the first index, the pane 2, I'll put directly the UI config acquisition. And I'm calling the start dynamic UI function of my UI framework. And the name of that dynamic container is going to be UI container config. Now I go listen to the UI manager broadcast event, UI ready to show. And if the name of the UI that is ready to show, it's been initialized, everything, events are ready to be fired, is UI container config, I call the show UI panel because it's ready to show. When I receive UI did stop, if this is my main UI, the UI container config that did stop because I clicked on the red X, I'm stopping my application and stopping the UI manager module. And in this VI, I'm going to handle the item selection changed event, broadcast event of my list. So a code that is very similar to what we had in our API tester. And when we are in the no error case, this means that this is type of item selected event at index 1. I typecast the UI broadcast so I can retrieve the text of the item that has been selected. And if the text is logger, I'm going to put the UI config logger UI module in the pane 2 of my container config. So I'm calling the change UI function of my framework. And if the text is acquisition, I load UI config acquisition in pane 2 of my container. That's pretty much it for this example. Let's execute this code with highlight execution, so you can see. So we start the UI manager module, we register for events, synchronize module events, we receive immediately the UI manager module did init, we start our list, we send the list of items and we select the index, and we launch our dynamic container. Then we receive the UI ready to show for the UI list that was started first, we don't care, and then the container, and we show its UI. And guess what? On the left, we have the list, and on the right, we have our UI config. Now, if I change and select logger, I receive the UI broadcast item selection change. I typecast it so I can get the text. It's logger, so I'm going to change the UI. And you can see that the framework did respect the minimum pane size of my UI config logger and automatically enlarged itself. That comes for free in the framework. Of course, the free means a lot of hours of development. And LabVIEW specialness of wrong resizing behavior, as many of you probably experienced. So when I created, I have some, when I create my container, I can define a lot of properties. By default, the splitter is not locked, but I could lock the splitter. I could change its color, its size, whatever. But what I want to show here is that it always respects the minimum size that I've defined for each UI module. So if I change back to acquisition, it didn't reduce the size because it would look wired in the regular execution flow, but then you can still reduce if you want. To end this demonstration, I'd like to show you the API tester of the UI manager. So remember, the UI manager is a DQMH module that defines the software API of our UI framework. It comes with an API tester that can be extremely useful for debugging. The API tester is going to be available also when the application is built and is executable. And like any other API tester, it also serves as a documentation of how to use the UI framework and what you can do with it. So let's use the API tester to create and manipulate a dynamic UI container that contains our listbox UI module. So I go to the dynamic UI container section of the API tester, and I'm going to create container 1, vertically splitted, that contains UI list instance 1 and UI list instance 2. I start that container, then I'm going to check list registered UIs. It registered my container 1 and each instance of the UI list as expected. I create another container, container 2, with instance 3 and 4 of my UI lists. And finally, container 3, very original names, this time divided horizontally. And on the top, I'll put my container 1, and on the bottom, my container 2. All that dynamically while the application is running. And now I'll select my container 3 and show its UI panel. And we have, as expected, 4 UI list instances that we can manipulate individually. So you saw that by default, the behavior, I changed that later. The default behavior now is for the splitter is to resize proportional and not stick to top left. But I'll show that later in an example. So from my UI manager API tester that I could bring from my executable by launching my application with --debug command line arguments, for example, I can also bring up any UI API tester and test my UIs directly from the built application, and as you can see, send some items to the instance 1 and 4 of my UI list. And let's continue to play. I create another container, horizontal, with a 5th instance of my UI list, and my container 3 at the bottom. I start that, and the container 3 disappeared, and now it's going to show in the bottom pane of my new container that I just dynamically created. So that API tester is extremely powerful and useful for debugging. If I show the module pane of my UI manager, it actually shows a representation of the UI. So I can see all my containers, how they are nested in each other's, and which UI and the size and the minimum size is in each pane of each container. The UI Manager framework comes with a lot of other features, for example, undocking a UI. So here you can see that I just removed a container from this bigger container. So now I have one container that is empty. The pane 2 of my container 3 is empty. And it's now, my container 2 is now a standalone container, standalone UI. I'm going to play just a little bit more, because I like to play with this UI Manager. I find it's quite magic, but you'll tell me at the end what you think about that, because I'm very interested if I'm doing something that could be useful or if I'm just losing my time. So I'm recreating container 1 with instance 1 and 2 of my UI list, container 2 with instance 3 and 4. But this time you can see that I changed the splitter color, so it's easy to see where the splitter bars are, and I'm putting the splitter sizing proportional, which is, in my latest build, the default behavior if you don't set anything. And I'm going to show this, and now when you resize, all the UI lists keep the same size. So you remember I say the framework comes with rules, benefits, and constraints, and some of the benefits I'd like to highlight here. It's the common design. This framework provides basic functionality that doesn't need to be duplicated within each application. Provides reuse, allow UIs to be independent from the business logic of our specific application, so you can reuse them across several different applications. It saves the developer a lot of time and effort of having to start from scratch for every new application. Even for a very simple app, it saves time to start with some framework like that. A lot of features, resizing, docking, undocking, busy cursor, lookup of the UIs in the call chain and hierarchies, PPL friendly, UI Manager and UI Modules API testers. And the structure for creating and displaying UIs is already in place with guidance on how to use, so it facilitates the developments of large applications. Extensibility and flexibility. Let's say I want to add localization of my UIs. I could do that directly from the framework without touching any of my already developed UI modules. So I can add more features as I need them, because all my UI modules are built in a frame that I'm aware of. Now it comes with inconvenience. I said rules, you have to follow the rules. The rules for being able to reuse a UI is that the UI should not handle any application-related business logic. You must keep it as generic as possible. Try to avoid dependencies to other UI modules or to other reusable libraries at all costs, except for some particular cases. For example, if you think about a login UI, it can be coupled with the forgot password UI, because they will always work together. But other than that, you need to respect this rule of making that as generic as possible if you want to reuse. And that's probably the main purpose of this framework. I mean, one of the biggest purposes. The constraints, there are several constraints, but probably the most obvious one is the container divided in two. If you want to show three things, you need to have two containers to do that. That's one of the constraints. The biggest inconvenience I faced while using this UI framework is the change of mindset you need to operate. It's so tempting when you start generating your UI module to just continue coding the associated business logic and do stuff that will make your UI module not generic, especially since it's a DQMH module and you have your event handling loop and message handling loop and everything is nice. But you must stick to something very generic and purely UI related. And there is definitely a learning curve as how you use the software API. At the moment, did I gain in productivity? I'm confident that I can, but at the moment, I'm still learning how to use this framework and to really make the proper use of it. Thank you very much for your attention. So we have a few minutes for questions. I'm particularly interested to hear your feedback, especially is it useful to have reusable UIs? Do you have something comparable maybe you'd like to share? Are you interested in dynamic UI composition? Why? Which use cases? How much UI scaling is a pain for you? I'm sure Anna is interested to hear about that too. If you have maybe some cases that will be addressed by this framework or not be addressed by this framework. So happy to hear your questions. Paul?
Hi, Matthias. That looks amazing. I've done some vaguely similar things before, and you might be able to tie in some of the Q control stuff. Mm-hmm. So I combined a Q control and a DQMH to make none of the container stuff, but some of the individual UI stuff happen, because it gives you the VI server stuff very quickly.
You're right. I didn't thought about that.
So I don't know whether you can quite do it the same way I did, but it looks like it might be possible to think about that. But no, that looked really cool.
Thank you. Definitely interesting to look at that.
Yeah, thank you for the great, yeah, here in the middle.
Oh, yeah. Yeah, okay, thank you.
Some lights would be nice. We have been looking into making custom user interfaces for test stand, and we actually ran into some cases that might not be addressed by the framework, since it seems to be based on the splitter bar, and then you have to split your user interface in
unless you display just a UI module standalone without any container in the game. That's also possible.
Okay, yeah.
You don't have to use container. But if you want to build a complex UI with several reusable parts, you're going to combine them into a single UI using containers. But you don't have to.
All right, thanks.
Rocio?
Okay, thank you. We are not using the QMH. We are using Actor Framework, and so we are using the panel actors made by MGI. It's actually really similar to what you have. We have using for a particular customer that has like 3-4 different applications based on a main application. So we actually build the business logic that can handle all the particularities, and then they chose directly the modules, and these modules actually have their own UIs. So they can make their own applications quickly with the different UIs for specific applications using the same blocks of code. Now, yes, it actually helps us to quickly reuse all the code, and actually has helped with the personalization, because they also do customer applications. So it's like a research center that has their own other research centers that they produced, and so the personalization of the UIs is actually useful. Now we do use the scaling UIs, and yes, we are actually doing with the panels and splitters, and it is painful at the beginning when you have to define. We do also use the part of giving the minimum size of the panels. That is actually helpful. We actually said that, for example, the trees and the graphs, they're going to resize with the UI, but the controls on the buttons, we keep them, you know.
So I'm not the only fool to do this kind of things.
No,
Cool.
no, you're not.
That's nice to hear.
I think Alan wants to speak.
Hi, Matthias.
Hi.
Thank you for this deep dive into code. It's always a pleasure to see it. I've got a question regarding this user interface topic. Because it's based on DQMH, I recently used a similar approach from Jörg with this Windows application template where quite similar requirements
there are similarities,
fulfilled. What I would like to know is, you big Jedi Knights of the DQMH universe, are you collaborating on this kind of requirements when it's about DQMH modules which fulfill at the end some kind of similar requirements? And
so I didn't
does it
have
influence each other?
So yeah, as you know, I'm part of the DQMH consortium, so it's easy for me to have the inside view. For this particular UI framework, I didn't have to request anything particular to be changed in the existing DQMH framework, but it was certainly useful to know the people who are doing scripting of the modules, to redo my own scripting tools on the top of that and don't have to reinvent the wheel because the scripting tools exist. And this is not things that are especially documented, but that the consortium will be pleased to answer anyone who has a particular need, and like I had a need to reuse the scripting tools, I was able to get more information to reuse them. But I didn't have to request any particular change. I tried really to use the DQMH framework as it is, and it's important to note that running the validation tool, the validation module tool, as it comes with DQMH on any UI module, works and will give a full pass and allows me also to upgrade my UI modules to the latest flavor of DQMH. Yes, Alan.
The previous commenter over here actually beat me to the MGI's panel manager, which does this for Actor Framework, and this is the way. This is what we should be doing. The only thing I really have to add is that this kind of eliminates the need for X controls, because just write your actor or your DQMH module to do your special control stuff, and then you just have it forever, which is nice.
Yeah, the next UI module I want to do probably is a button, where I'll be able to change the glyph, the color, everything. It's not going to be a button. It's going to be a picture control and stuff like that, but a really fancy, powerful button that I can reuse and customize for any application, any project, and then I can reuse that, yeah.
First time I got to play with this really hard was a customer that was building a product that has little 400 by 600 display in a clean room where everybody was double gloved, and we had to redo all of the LabVIEW controls that we wanted to use to make them big enough to use your gloved thumb on. And I mean, it was what we had to do, because we had to we were building these controls from scratch, basically.
Yeah. Thank you very much. I think I'm out of time.
Thank you, Matthias.